Welcome to Manmaker. I am Ranjan Kumar, and today we are going to see some more electronics important and expected question with details explanation. And these questions are based on previous year and exam pattern. Okay, as we have covered so many questions till now, and I hope you have covered, you have practiced these questions from this ebook which I gave you. So here, as you can see, I hope you have completed this 600 MCQ important question, and their detailed solution also you have noted down that one also. And here also subject wise MCQ and notes you have completed, I think. And till now we have covered 12 important question mock test. So today we are going to do 13 mock test, I mean practice session. There we are going to see more questions about your exam. Okay, and those who haven't taken till now this study material, you can take this one, still time is there. And you are an engineer, so you have a ability to complete the syllabus within 1 day before of exam also. So still time is there. Just if you want to practice some more question, if you want to feel good preparation for your exam, just take and prepare these all. Okay. Okay, so we'll start. Join our Telegram channel. You can directly go to Telegram and search this Hard Work Limited. You will get this channel. Otherwise, in a description box, you will get the link. Just join this one. You will get here PDF notes, classes, and daily updates. Everything you will get in this channel. Okay, Telegram. So we will start. An idle op amp is an idle. Idle op amp, if we see the idle about idle op amp, then V out is equal to AV in. Okay, so we can say that it is op amp is a voltage control voltage source. Okay, so we can say that like op amp is a voltage control voltage source. Apart from this, okay, this is the answer for this question. Apart from this, you have to remember for about op amp, you can say characteristic of op amp or property of op amp. Op amp, in op amp always voltage gain, open loop voltage gain is infinity. Okay, open loop voltage gain is infinity. And input impedance is always infinity. Okay, then one thing is CMRR, that is equal to common mode rejection ratio, is also infinity. Then slew rate is always infinity. Okay, then bandwidth of op amp is always infinity. Okay, apart from this, if you talk about output impedance is 0. offset value offset value or offset voltage is 0. And PSRR, okay, PSRR, power supply rejection ratio, is also 0. Okay, so these all points you have to remember for op amp. Any question they may ask in your exam. Okay, so every point you have to remember about op amp. Next, the output of the logic gate in a figure is. So this is what this is. This gate, this symbol is for XNOR gate. Okay, XNOR gate. And if you see the truth table for XNOR, A and B, and this is what output. Okay, you can denote this output as A XNOR B, like this formula for the output. So 0 0 0 1 1 0 and 1 1. In a XNOR, whenever two input are both are similar, then only output will be type. Okay, otherwise it will be 0. So here anyhow this is ground, so B is always 0. Okay, now if we put A equal to 1 and B we have already 0, then output will become 1 and 0, 1 and 0, so output will be 0. Okay, so what and another case, when A is 0 and B is already 0, so in this case output is what? 0 0 means 1. So what we are getting in output? 0 and 1 when we will put some A value. So whenever A value is 1, output we are getting 0. whenever A is 0, output we are getting 1. Means whatever A is there, we are in output we are getting A complement. Okay, opposite of A. A complement we are getting. So from here option C will be right answer. A transmission line of 50 ohm characteristic impedance is terminated with a 100 ohm resistance. The minimum impedance measured on the line is equal to. So minimum, if you see, for calculation of maximum impedance, okay, maximum impedance, that is Z max is equal to Z naught into VSWR, and Z min, that is minimum impedance is equal to Z naught divided by VSWR. Okay, so here we need to find minimum impedance, that is Z min we need to calculate. Okay, and here what we have to here we have 50 ohm, that is characteristic impedance, means we have Z naught value of 50 ohm, and we have terminated resistance, that is ZL, we have 100 ohm. Okay, so now we have to find Z min, but we don't know the value of VSWR. So VSWR is what? VSWR is voltage standing wave ratio. That is how we will find VSWR is equal to 1 plus xi divided by 1 minus xi. This xi is what? This symbol is called reflection coefficient. Okay, this is what? Reflection coefficient. Now we don't know the value of xi also. So xi is what? Reflection coefficient. And reflection coefficient, how we will calculate that the reflection coefficient is equal to ZL minus Z naught divided by ZL plus Z naught. Okay, that is equal to ZL, we have 100 minus 50 divided by 100 plus 50, and that is equal to 50 divided by 150, and this is 1 by 3. Now we got the value of reflection coefficient, so we can easily calculate VSWR. VSWR is equal to 1 plus xi divided by 1 minus xi. Okay, so this is 1 plus 1 by 3, and this is 1 minus 1 by 3. If you calculate this thing, then you will get like this, 3 minus 1 by 3. Okay, so this is what? 4 by 2, or this is equal to 2. Okay, now we got the value of VSWR. Now we have to calculate what? Minimum impedance, that is equal to Z minimum is equal to Z naught divided by VSWR. Okay, so Z naught is how much? It is 50, and VSWR we got 2, that is equal to 25 ohm is your answer, option. Okay, if they will ask Z max, then you have to put this formula for maximum impedance, but here they asked minimum, so it is minimum. For a voltage follower circuit using op amp, which of the following is true? Voltage follower circuit is what? Voltage follower circuit is mainly used as a buffer circuit. Okay, used as a buffer amplifier, isolate isolation amplifier, and unity gain amplifier. Oh, so voltage follower circuit is used as a buffer amplifier, isolation amplifier, and unity gain amplifier. So they may ask this question also, so you have to remember this thing. Now if you see the characteristic or properties of this voltage follower, so it has it has it has high input, it has high input impedance. Okay, it has high input impedance, then it has low output impedance, okay. Voltage follower has high input impedance, voltage follower has a low input impedance, and it has high power gain, high power gain, then high voltage gain, voltage, voltage gain, and high current gain. Okay, high current gain. So these are the characteristic of voltage follower. So here in the option you can see the option B. It has input impedance very large and output impedance very small. So this is the characteristic of voltage follower circuit. Okay. Next 5 MOSFET. MOSFET is what? MOSFET is metal oxide semiconductor field effect transistor. If you see the symbol, so like this symbol will be there for MOSFET. This is like this one and this one. So this is what? This is gate, this is your drain, and this is your source. Generally, MOSFET is separated by a thin layer of this gate and channel with a SiO2 layer. Okay, and this form a capacitor. So we call MOS capacitance to MOSFET for capacitance. Okay, sometimes where MOSFET is called as a MOS capacitance, and this MOS capacitance is varied by VGS, that is gate to source voltage. So it will we can say that this is voltage controlled capacitor because it is controlling by gate to source voltage. Okay. So this is option B is the right answer from here. Next, a cascode amplifier stage is equivalent to. So we have some amplifier configuration. Okay, we have some amplifier configuration. That is why. That is what. That is one is cascade. Cascade. Okay, cascade amplifier. Then another one is cascode amplifier. Okay, and Darlington pair. Darlington pair. Okay, Darlington pair. Okay, for a cascade, this is cascade, this is cascode. Both are different. Okay, so cascade is what? Cascade is generally followed. Cascade is a common emitter which is followed by cascade followed by common control. Okay, cascade amplifier is a cascaded with CE means common emitter and it is followed by common collector. Likewise, cascode is again this is common emitter and followed by common base. And Darlington pair is cascaded with common collector and it is followed by again common collector. So this 3 point you also have to remember. Here from the question, a cascode amplifier stage is equivalent to equivalent to CE and CV. So common emitter stage followed by a common base stage. Okay, this is the answer. Now, a device that makes possible to use the same antenna for a transmission and reception both is called duplexer. We have three type of communication channel: simplex, half simplex, half duplex, and duplex. Okay, duplex or full duplex. So simplex means what? What? One-way communication. One-way communication. Okay, in one way we can do communication like television. Then half duplex is what? This is two-way communication. This is two-way communication, but not in a same time. But not in same time. Okay, means one time either you can receive the signal or transmit the signal like walkie-talkie. Then duplexer or full duplex. This is also a two-way communication. This is also a two-way communication in same time. Means at a time you can transmit the signal and receive the signal like our telephone. So from here option A will be the right answer. Okay. Now magic T. Magic T is a combination of magic T is what? Magic T is a microwave device. Magic T is a microwave device that is used for combine the power, isolate the circuit and mix the signal or divide the power. For that magic T is used. And this is a combination of one H plan T and one E plan T. Okay, this is the answer. Binary number 110, we have 1101 and we have 101, we have to perform addition. Okay, so generally we will know 0 plus 0 is what? 0, 0 plus 1 is what? 1, and 1 plus 0 is what? 1, and 1 plus 1 is what? 10. That is 1 is carry with 0. So like this 1 plus 1 is what? 10, that is 0 and 1 carry. So 1 plus 0 is 1, then again 1 plus 0 is what? 1. Okay. Here 1 plus 1 is 10, so 0 and 1 carry. So 1 plus 1 is 10. So this is your answer. Option B is the right answer. Okay. Yagi Uda. Yagi Uda array does not have. Yagi Uda antenna. Generally, Yagi Uda antenna is what? Yagi Uda antenna is a directional, unidirectional, unidirectional, unidirectional antenna. Okay, it is what? Unidirectional antenna, and it has high gain. It has high gain. It has parasite reflector that is less than lambda by 2, and it has director that is greater than lambda by 2. Okay, but it don't have high bandwidth. It has low bandwidth. Okay, it has low bandwidth. So option B will be your answer, because it asks does not have. So it does not have high bandwidth, it has low bandwidth. Okay, this is the answer. The transformer utilization factor of DC power supply may be defined as, so TUF. TUF, transformer utilization factor, is used to measure the merit of rectifier circuit, and this is defined as DC power delivered to load divided by AC rating of transfer secondary. Okay. Now, in the question, they may ask what is the TUF for, means transfer utilized factor of half wave rectifier, center tape rectifier, center tape full wave rectifier, and breeze wave full wave rectifier. Okay, so they may ask this question. So this is what half wave rectifier is 28.6%, then center tape is 57.2%, and bandwidth of TUF of breeze wave rectifier is 81%. Okay, so this thing you just remember, because they may ask this question also. Okay, the transmitter power is 10 watt. It is increased by an antenna gain of 30 dB. The effective radiated power, that is ERP. ERP is what? G and PT. G into PT. G is gain antenna and P is transmitted power. But G should be not in dB. So first we need to find a gain. So generally how we are calculating gain in dB is equal to 10 log base 10 and G. Okay. So here we know this is 30 equal to 10 log 10. This is G, and this 0 0 cancel. Now if you do anti-log, then you can write this thing 10 to the power 3 equal to G. Okay, or G equal to, we got 10 means 1000, and now we can find ERP. Okay, ERP, that is effective radiated power, is equal to G into PT. G is 1000 and PT we have given 10, that is equal to 10,000 watt. Okay, this is your answer, option C. Like this you need to calculate. Now 200 microseconds should be the memory size of a digital storage oscilloscope to be able to record a transition of 10 seconds with a time resolution of 200 microseconds. So for memory size, we need to calculate what? Memory size. So memory size is equal to what? Memory size is equal to sample record time and divided by resolution time. Okay, resolution time. So we have everything, just we need to calculate. Sample recorded time is how much? 10 second, and this is 200 microsecond, that is 10 to the power minus 6. We can write like this. So 10 into 10 to the power 6 divided by 200, we can do like this. This 0 cancel, this 0 and this cancel, so this is 5. Now we can write this 10 to the power 5 as a 100 into 10 to the power 3 and divided by 2. This cancel, this is what? 50. So this is 50 into 10 to the power 3, or we can write 50k. Option P is the right answer. The wavelength in meter of an electromagnetic wave is related to its frequency in megahertz. So generally, what is the relation between lambda and frequency? Is lambda equal to c by f. Okay, c is what? C is velocity of light, that is equal to 3 into 10 to the power 8 meter per second, and frequency in hertz. Okay, but here frequency they have asked in megahertz, so we can write f into megahertz means 10 to the power 6. And now this we can make a calculation. This is what? 2. So this is what? 3 into 10 to the power 2 divided by f, or we can write 300 divided by f, that is equal to option C is your answer. With the reference of satellite orbit, Pirizi is the. So if you see, this is Earth, okay? This is Earth and this is orbit. This is suppose satellite or any planet. So the shortest or nearest point of a orbit is called Pirizi. Okay, it's called Pirizi, and this is rotate in a orbit in a nature. And the longest point, this is the longest point. Okay, this is longest point. Longest point is called apogee. Okay, so longest point of satellite from the Earth is called apogee, and here they ask about perigee. So this is the lowest point in the orbit. If they will ask highest point means about apogee, so answer will be highest point of the orbit. Option C is the right answer from here. Noise figure of an amplifier does not depend on. Noise figure is what? Noise figure is what? This is the ratio of input SNR, that is signal to noise ratio, divided by output SNR, that is signal to noise ratio. Okay, this is the noise figure formula. So this is depend upon input voltage. Okay, this is input power and output power, but it does not depend on bandwidth. So answer will be what? Answer will be your bandwidth. Option is the right answer. The velocity of electromagnetic wave in a dielectric medium with relative permittivity of 4 will be. So if you see, the velocity of EM wave is what? C divided by this is what? Permittivity, that is equal to mu r. Okay, this is what? Permittivity. So C we know, 3 into 10 to the power 8 meter per second, that is what? Velocity of light, and this is given 4. So 3 into 10 to the power 8 divided by this is 2, or we can write 1.5 into 10 to the power 8 meter per second. That is your answer, option C. 100 ohm 1 watt composition of film resistor can sustain across it a maximum voltage of. We need to find voltage. We have power is 1 watt and resistance given 100 ohm. So what is the relation of power? So this is what V square by R. We need to find V square, so we can write P and R. P we have 1 watt and R we have 100. So this is what this is 100. So V square is equal to 100. We need to find V. So it will become root under. So this is what 10 volt. This is your answer, option A. Okay. Now, in a modulation system, the modulating voltage remains the same. The modulation index is half when the modulating frequency is double in the system is. So, if you see the index, modulation index is what? Modulation index of AM signal. If you see the modulation index of AM signal, that will be denoted by mu. This is equal to what? AM by AC. Okay. Amplitude, maximum amplitude divided by carrier amplitude signal. Now for PM, that is phase modulation. So phase modulation is what? Beta equal to Kp into AM. This is the modulation index formula. Now for FM, that is frequency modulation. This is again beta equal to Kf AM divided by FM. Okay. So if you see these two means AM and PM is not dependent of frequency. Okay, not dependent of frequency. These are independent of frequency, but only FM is what it is dependent of frequency. And they have asked about like if modulation index is half when the modulating frequency is double. So we have to make this FM as a 2FM like this they are asking. So in this case only we can apply this situation. So here answer will be option B is your right answer. Okay. In a class B power amplifier, output is dash of the input full cycle. Okay. If we see the power amplifier, generally we have four type of power amplifier. Class A amplifier, class B amplifier, class C amplifier, and class A B amplifier. So we have four type of amplifier: class A amplifier, class B amplifier, class C, and class AB amplifier. If we talk about output waveform in a class A amplifier, output waveform will be the full of input waveform, full of input cycle, input full cycle. Okay, input cycle. And in class B, it will be the half of input waveform. Okay. In class C, it will be the less than half cycle of input, and in class AB, it is more than half but less than full of input cycle. Okay, this 4 point you need to remember anything they will ask in exam. Okay, in a class A full it will come full output. In output full wave come for a input cycle, and class B half waveform will come. In class C less than half waveform come, and in class AB more than half but less than full waveform will be come. Okay, so according to this we can say about conduction angle of amplifier. In class A amplifier, it is a full waveform they will give in output. So here the conduction waveform will be how much? 360 degree. And class B is a half waveform means 180 degree. And class C less than half means less than 180 degree. And class AB is more than half but less than full means the conduction angle will lie between 180 degree to 360 degree. Okay, this thing also you need to remember about conduction angle of amplifier. And sometimes they will ask also one more thing, efficiency. efficiency of amplifier. So in a class A amplifier, efficiency will be your 25% to 50%. In class B, it will be 78.5%, and class C, it is less than 50%, and in class AB it will be 50% to 78%. Okay, so whatever is there in this table, they may ask any kind of question, like in a class A, what is the conduction angle? So it is 360 degree. Okay, what is the efficiency of class B amplifier? So it is 78.5%. So like that they will make question. Okay, so whatever I am going to explain, that thing you have to remember, that you need to note down. From that also question will be come. Okay. Next question. A transformer is a dash device. Generally devices, we have two kind of devices. Generally we will divide devices in a two part. One is active and another one is passive device. Okay, active device means what? Active device means who required, which required external power, to operate. Okay, external power to operate. And in passive, no external power required, no external power required to operate. Okay. So active devices means who? Active devices means what? Like LEDs, then diode, then transistor, amplifier. These are the example of active devices. In passive devices are L, C and transformer. Okay. Resistor, inductance, capacitor and transformer are what? Passive element or passive device. So here transformer is a passive device. Option B will be the right answer. Okay. Frequency in UHF range propagate by means of. UHF means ultra high frequency. Okay. So if we see about ground wave, in ground wave generally frequency will be in ground wave generally frequency will be low frequency, in a range of low frequency, or very low frequency, and medium frequency we are using in a ground wave. If we see the range for ground wave, then the range will be around 3 range will be around, just a second, so range will be around 3 kilohertz, 3 kilohertz to 300 kilohertz. Okay. And skywave we are using high frequency. Skywave, we are using high frequency, that is the range of 300 kilohertz to 300 megahertz. Okay. And space wave we are using very high frequency. This is very high frequency, then ultra high frequency and super high frequency. Okay, in the range of 300 megahertz to 3000 gigahertz. Okay, so like that you have to remember every point. Okay, so here UHF means ultra high frequency, so answer will be space wave. So these all points you have to remember. What is the range of high frequency? They will ask question. You have to answer 300 kilohertz to 300 megahertz. Which frequency we are using in ground wave? So we are using low frequency, very low frequency, medium frequency. This is the answer. So like that question will be come. For a given circuit, the forward resistance of PN junction is 50 ohm and the reverse resistance is infinity. Then circuit following through 100 ohm resistor is what? Okay. So what they told, for a given circuit, the forward resistance of PN junction is 50 ohm. Forward junction is what? Forward junction is 50 ohm. Okay. Forward PN junction means this one is a forward bias. So this is what 50 ohm resistance. Okay, and the reverse diode is infinity. This one is infinity. Infinity means it will act as a open circuit. So we can redraw this circuit as a like this. We can change this one in resistance, and we can make this circuit again. Infinity means open circuit, and this will be like this. Here 6-volt battery, one resistor, and this is the circuit diagram. This is how much? 50 ohm. This is 150 ohm. This is again 150 ohm, and this is 100 ohm, and this is 6 volt. Okay, so now we can redraw this circuit again like this. This is open circuit, so current will be here. This is open circuit, so no, not required this one, because current will not flow here. So we can remove that one. This is 100 ohm. This is 6 volt. This is 50 volt, 50 ohm, and this is 150 ohm. Okay, so now we have to found the current flowing through 100 ohm resistance. So we can put here what? KVL. So KVL we will apply here. KVL. So if we apply, this is plus, this is minus, this is plus, this is minus, plus, minus, this is plus and minus. So we have to go like this. Okay, so whatever, like if you are choosing this plus position means outgoing, so it will be 6 volt minus, this is what? I means 50I. Okay, again minus 150I and minus 100I equal to 0. Like this we can write from KVL. Okay, so 6 volt is what? Minus 50. This is the 100, 150 and 50 is around 300I. Okay, equal to 0. And 6 volt equal to, we can write 300I, and I equal to what? I equal to 6 by 300. That is what? That is 2 by 100, and we can write this one 0.02 ampere. Option B is the right answer. Okay, next. It here I gave the answer. Oh, here first is a half. Okay, option B is the right answer in first question. Now 4 is okay. Now fifth question. A 240 kilohertz 10 VPP carrier is amplitude modulated using 1 kilohertz sine wave of 3 VPP. What is the modulation index? Modulation index is what? Modulation index is generally we are denote with U. Mu. Mu equal to AM by AC. AM is AM is what? AM is a peak to peak voltage, that is VPP, peak to peak voltage of message signal. Okay, and this is what? AC is what? AC is again peak to peak voltage of carrier signal. carrier Signal. Okay, so here what we have, here we have VPP, 10 VPP carrier signal. So AC we have peak to peak voltage of carrier signal is what? 10 volt, 10 volt, and this is amplitude modulated using 1 kilohertz sine wave. Amplitude modulated means message signal we have given 3 VPP, 3 volt we can say. So we can put this one here. This is 3 by 10. That is equal to what? 0.3. So 0.3 is your answer, option B. Okay. Now one more thing you should remember here. They will ask some question like this. When condition they will give, when mu is means modulation index is less than 1, then it is called under modulation. Okay, under modulation. When mu is equal to 1, then it is called perfect modulation, and mu is greater than 1, then it is called over modulation. So this 3 point you need to remember. Okay, they will ask sometime like If modulation index is 1, then what kind of modulation it is? So you have to answer perfect modulation. Like this you have to remember. Okay. The phase shift between input and output of an emitter follower is, generally we have transistor configuration. So generally we have three type of transistor configuration: common emitter configuration, common base configuration, and common collector configuration. This common collector is also called as a emitter follower, emitter follower circuit. Okay, this is also called common collector, is also called emitter follower circuit. Now if we talk for phase shift between input and output, then in C common emitter it will be 180 degree, in common base it is 0 degree, and in common collector, that is emitter follower, it is 0 degree phase shift. Okay, so here our answer will be what? Phase shift between input and output of emitter follower means collector, common collector, so 0 degree. Option A is the right answer. Sometime they will ask about power gain. What is the power gain of common emitter? So it is high. Okay, it is high. Common base is moderate, and common collector have low power gain. Like this you need to remember the point. Okay, now diodes which are used in voltage regulator are, in voltage regulator, what kind of diode we are using? Zener diode we are using in a voltage regulator. When, in which condition? When it is in breakdown region. Breakdown region. When Zener diode is in breakdown region, then it is used as a voltage regulation application. Okay. Now input and output quantities in field effect transistor are nonlinear related due to square term is what? Shockley equation. Shockley equation, what is this? Shockley equation gives current equation of field effect transistor. That is what? ID equal to IDSS 1 minus VGS by VP whole square. Okay, where ID is what? ID is your drain current, drain current. IDSS is what? IDSS is drain to source current. Then VGS is what? VGS is your gate to source voltage. Okay, and then VP is what? VP is called pinch of voltage. Okay, this formula you need to remember. This is Shockley equation. Okay, Shockley equation formula. Now we have to simplify these things. This is what? Boolean algebra, you know. Question is from digital, so I think you know about Boolean algebra. So this is B plus C. Now what we will do? We can write this thing AB plus this one. We can write AB plus AC, and here we can write BB plus BC. Okay, now this thing AB and AB, generally this A plus A is what? A plus A is what? A plus A is A. So we can write this AB plus AB as a AB plus this is what? A B dot B. So A dot A is what? A dot A is A. So we can write this one again, B dot B as a only B. Then plus BC. Okay. Now this is AB plus AC, and from here we can take B common and we can write 1 plus C. Now again 1 plus A is what? 1 plus A is 1. Okay. So these all are the this is Boolean equation. Okay, these things are Boolean formula, you can say. So we can write this thing AB plus AC and plus this is 1, A plus C become 1. So because A plus 1 plus A is 1, means 1 plus anything is 1. So this is B. Okay. Now again, if you take common from this thing, if we take common B, then we can write A plus 1, and this is what? AC. Okay. Again, this thing what? 1. So this is B plus AC, and this is the answer. Option B is right answer. Like this, you need to solve the question. Okay. A series RLC circuit supplied by 220-volt AC voltage has R is 10 ohm, L is 10 millihenry, and C equal to 1 microfarad. Find the quality factor of an inductor at resonance circuit. Okay. So quality factor is what? Quality factor is frequency by bandwidth. Okay, quality factor is what? Frequency by bandwidth. And we can write this thing, quality factor is what? In a quality factor for resonance circuit is what? 1 by R under root L by C. Okay, so everything we have 1 by R we know 10 ohm, L we know how much? 10 millihenry. So 10 into 10 to the power minus 3. And capacitor is 1 microfarad, that is 1 into 10 to the power minus 6. Now we need to solve this one. 1 by 10. This is, we can write 10 into 10 to the power minus 3 and into 10 to the power 6. Like this we can write. And again, this is 1 by 10. And this will become 10 into 10 3, or this is 1 by 10. We can write 10000. Okay, 40. And this is 1 by 10 under root, so it will come 100. This gone, so this is 10. Option A is the right answer. Okay. Next, Siemens is the SI unit of dash. Siemens is the SI unit of what? Conduction. Siemens is the SI unit of conduction, and we can denote Siemens. This is conduction is G, and Siemens means what? Like this symbol will be there for Siemens. Conductivity, if we talk about conductivity what? Conductivity we can denote like this, and SI unit of conductivity is SI unit is what? Siemens. SI unit is what? SI unit is Siemens per meter. Siemens per meter. Okay. And resistivity is what? Rho. Resistivity, if we see SI unit of resistivity is what? Ohm meter. Okay, ohm meter. And resistance is R. RSI unit is what? Ohm. Everyone knows this thing, ohm. Okay, so here option B is the right answer. The phase modulation and amplitude modulation are considered as a special case of dash. So we have digital to analog modulation scheme. So we have three digital to analog modulation scheme: FSK, PSK, PSK, and ASK. ASK. Okay, FSK, PSK, and ASK. Frequency shifting, phase shifting, and amplitude shifting. Okay, and we have one thing, QAM, quadrature amplitude modulation. Here in quadrature amplitude modulation, it will take phase and amplitude both. Okay, so that's why here the phase modulation and amplitude modulation are considered as a quadrature amplitude modulation. Okay, in the below circuit, the number of branches and nodes are. So branches means what? Branches means number of element. So this is one element, this is another one, this is another one, this is another one, this is another one. So total 1 2 3 4 and 5. 5 elements is there, means 5 branches there. And node means what? Node where two and more element are connected. Like if you see this voltage and this resistance is connected here, so this is one node. Here this resistance and this resistance is connected, so this is another node. and here this voltage and this resistance is connected. So this is another node, and this much node is there, 3 nodes. So 3. Option A is the right answer. 5 branches and 3 nodes. Okay. Which of the following gate can be used as a priority generation? Okay. So if we talk about logic gates, we have 3 type of logic gates. Okay. What are the 3 type of logic gates? I know you will say and or not. Okay. But that is another thing. Three type of logic gates are: one is basic gates, another one is universal gate, and the third one exclusive gate. So this is the 3 type of logic gates. In basic gate we are studying AND gate, OR gate, and NOT gate. Okay, 3 type of basic gates are there: AND, OR, and NOT. And universal gates are NAND and NOR. Okay, 2 gates are there: NAND and NOR. Exclusive gate is XOR, and XNOR. Okay, these are the gates. This is also written as XOR and XNOR. Like that, we can also write this gate. So this exclusive gates is used as a priority generation and checking. So option C is the right answer. Okay. Find the minimum number of NAND gate required to realize a XOR gate. Okay, so I will teach you one thing, one table. Just remember this table. This is what? This is NAND and this is NOR. Okay. Just remember this table. It will help you for every exam. This is NOT, then AND, this is OR, XOR, and XNOR. Okay. So if this is 1 and 1, okay, this is 2, this is 3, again cross this one, 3 and 2, this is 4, this is 5, again cross this one, this is 5 and this is 4. So whenever question came, anything it will come. Like here they ask, find the minimum number of NAND gate required to realize XOR gate. Realize what? XOR gate. So XOR gate, this one is XOR gate using NAND gate. Using NAND gate, how much required? 4 required. So 4 is the answer. If they will ask using NAND gate, realize OR gate, how many NAND gate required to realize an OR gate? So OR gate, 3 gate will be required. Answer will be 3. If they will ask how many NOR gate required to make AND gate, so this is again 3 answer. Like this you have to give answer. So remember this table for realization of any gate. Okay. So now 16. For an AND channel, one more thing here. Why universal gate? NAND and NOR gate is why universal gate, because using NAND or NOR gate we can make any kind of these gates. Okay, any basic gate we can make, and exclusive we can make. So that's why NAND and NOR are a universal gate. For an N channel enhancement MOSFET, ID increases when? So two condition is there for enhancement MOSFET. EMOS, we can say enhancement MOSFET. When VGS is greater than VT, means gate to source voltage is greater than threshold voltage, then ID will increase, or ID increases, or we can say ID is greater than 0. In this case, MOSFET is in on condition. Okay, on condition, and VGS is less than VT, then ID decreases. or we can say ID is less than 0. So in this case, MOSFET is off condition. Okay, so question will come like this, means what is the in following which one is the MOSFET in on condition? So you have to give answer VGS is greater than VT. Okay. Like this you need to remember. So here they ask ID increases. ID increases means drain current is increases. Drain current increases, in which case VGS is greater than VT. Option A is the right answer. Okay. Clamper is also known as. Clamper circuit is what? Clamper circuit is generally it will clamp the DC voltage without changing input without changing applied input signal. So generally it will clamp the DC level. So we can say DC restore to a clamper circuit. Okay. So option D is the right answer. Which of the following is not the correct representation of power? So here if you see, this is the power formula, this is also power formula, this is also power formula, but this one is not a power formula. So our answer will be option D is the right answer. Okay. So we have this kind of, this is the power formula. You have to remember power formula like this. One more is there, I square R, P equal to I square R. The unit of power is what? The unit of power is watt. Okay. SI unit is what? Watt. So this much only. In TV broadcasting, video signal are transmitted in dash and audio signal in transmitted in dash. Okay. So for video signal we are using AM and for audio signal we are using FM. Option A is the right answer. Amplitude modulation we are using for video signal and for audio signal we are using frequency modulation. One more question is there, like in television, which modulation scheme is used? Which modulation scheme is used? So this will be VSV. VSV. Okay. Digital sideband modulation. Okay. Correct. VSV. So this is the answer for this thing. Okay. This question you need to practice from this study guide, and I hope who has taken this thing, who and means who has taken this thing already, they have completed this like that question. And those who haven't taken, just take this one. Here you are going to get short notes of subject, whatever subject is there in your syllabus. So you will get subject wise short notes, subject wise MCQ. You need to practice with detailed explanation. It is there. Then 6 set of model paper means you are going to get 600 MCQ with details and solution. So these are important and expected question, like we have discussed in the video, like that you will get in the 600 MCQ. More question you will get, so you need to you will practice more questions. And some classes already I have taken in YouTube, that link I will share with you, which is related to your exam. Okay. So if you want this, just need to drop in this number. This is my WhatsApp number. Just drop a message and you can get this study material. And you can tell to your electrical people or computer people also who are applied for this. So for them also material is there. Just take this one and complete your preparation. Okay. As I told before, being an engineer, you know, you have a capability to complete a syllabus or notes. If you get one day before also exam, you have that much capability. As you are doing in a semester exam, one day before only you will prepare for exam. We know all these things, so still time is there. Okay, so that much only. And if you like this video, just hit like on a button, kindly share with your friends. And if you not subscribed my channel till now, just subscribe the channel and press the bell icon. Okay, thank you.